What's up, welding world? My name's Daniel. I'm a level 2 CWB welding inspector. Today I'm going to be going over the welding procedures, what they are, why they're important, the different sections, and I'll show you a sample and go through it piece by piece. All right, let's get started. So, what is a welding procedure? Okay, here we have a welding procedure. Basically, we know that if we always follow what's shown in the welding procedure, we will be able to produce sound welds that meet the minimum requirement of the codes. Welding procedures are generally designed by engineers or senior and well-experienced welders. They're then tested to see that they meet the requirements of the code. They're tested for tensile strength, impact, Sharpie tests. Sometimes other tests are required as well, depending on the code setting under certain conditions. Some welding procedures are considered pre-qualified, for example, in CSA W59.1, which is generally considered the structural welding code here in Canada. A lot of welding procedures that are general and are used very, very often, there's just simply enough information already in the welding databases to know that we don't really need to do destructive testing on the sample piece to know that these welds will work under these settings and these conditions. These are called pre-qualified welding procedures. All right, let's look at the different sections of a welding procedure. So here we have the sample welding procedure made by the Canadian Welding Bureau. In the top right, you have the WPDS number. So whatever number of welding procedure you are, you have the reference standard, the number again, the company name, and the company address. This is the very basic. Sometimes you have a phone number and other contact info. All right, here we have the next section where you would list the welding process and the shielding gas. So there's two parts here in case you're using two processes. For example, a root pass with one process and then second fill and cap pass with another process. It lists the shielding gas, if any. If there isn't, just write NA, and the same thing in the second process. You also have the option in this procedure sample to write whether or not it's pulsed. Okay, next section. On the right hand side, you'd have a sketch of the joint configuration and layers and the passes and any sequence that could be involved. On the left hand side here, and the positions: overhead, flat, vertical up, vertical down, horizontal. Process mode, whether manual, semi-auto. Joint type: butt, T, corner, lap, edge. Penetration, whether it's complete penetration, partial penetration, or fillet. If it's partial penetration, don't forget to list how much penetration. A backing, if any, the material and the thickness. Back gouging, yes, no, and then if yes, what is the method, whether it's carbon arc or plasma. Electrode extension, nozzle diameter, and flux classification. This is often in wire modes or SMAW. Tungsten electrode, that would be for TIG. Cleaning process, you could do mechanical or chemical, so whether wire brush on a grinder or some sort of chemical cleaning with acids. All right, moving on to the next section here, the identification of base material and the identification of filler material. This would come into your steel groups 1, 2, 3, 4, 5. So they're generally listed in the CSA codes or in ASME or P numbers. The identification of filler material, whatever that may be. In the case of sticks, say 7018, you will put the classification, not just the brand name. It's important to list the classification because that covers a broad range rather than simply one particular material. Next section here shows your welding parameters. So the thickness, the weld size. So again, put a range from minimum to maximum. The layer and the pass number, the welding process. Again, you could have several different processes going on. Diameter of wire, wire feed speed, your current and your amps, your current polarity, whether electrode negative or electrode positive, your welding speed. So this is easy, just time how long it takes to go a certain distance. Burn off rate if necessary, gas flow, and heat input. Heat input's a good one. Alright, your heat input's an important one. Here's the formula for it. So it's your voltage multiplied by your amperage times 60, all divided by your travel speed. This will give you your heat input in either joules per inch or joules per millimeter, depending on which system you're working with. This is important. If I come to witness a weld test or in-process welding, this is one of the things I'm going to be checking as an inspector. Remember to stay within your heat range. Okay, the last section here in our welding procedure, on the left hand side we have any heat treatments, so either any preheat or post heating, inner pass temperature minimum, inner pass temperature maximum, remarks, whatever you think could be important to put in there, CWB acceptance, whether you're doing it with CWB to a CSA code, or whether it's some sort of provincial jurisdiction, RBQ, TSSA, ABSA, Department of Labor, depending on what province you're in, then your company authorization or stamp, depending on what you have, perhaps an engineer stamp or an inspector stamp. Finally, the date underneath there. Okay, so now you're probably thinking, why the hell do I care about any of this stuff? So if you're working for any sort of decent company whatsoever, they're going to be certified to a CSA standard through CWB, or they may be a pressure company building tanks and piping, which will be registered under the provincial jurisdiction, like I was saying before. Maybe ABSA if you're in Alberta, TSSA, Department of Labor out east, RBQ here in Quebec. And it's important to have all these welding procedures in place, because if you don't, you really have no proof to show that anything you're doing is going to work and meet the requirements of the code. This is your go-to, it's your Bible when it comes to welding. If people argue with you and you're working within the procedure, tell them to get stuck. Look, my settings are within the procedure, I'm meeting my heat input range, and I'm all good. If you're working with some old dude who's going on some bullshit about how this is the way they've always done it and nothing should ever change ever under any circumstances ever because I'm old and I know everything, again, pull out the welding procedure, show them, hey look bud, you've been doing it wrong for 30 years, sorry, do it right. This goes for QC personnel, supervisors, and welders. Again, why this is important: by doing the welding inspection, going through the steps, testing it, having it all witnessed, done properly in the laboratory, doing destructive testing, we know that so long as our welders are qualified to these procedures through their own destructive testing, for example, when you do your CWB test plates or pipe tests, we know that as long as we follow these settings and these steps and this sequence on this material with this filler metal, we'll be good. We'll produce sound welds that meet the requirements of the code. So stick to your procedures, work within the parameters of them, and you'll be fine 99% of the time. You can always get some bad lot of welding electrodes or bad material, who knows. You can always trace that back with your mill test reports and find out if there was problems and trend it off. All right, if you have any suggestions for other videos that you would like me to make, leave comments, and I'll try to address any questions that may come up. Thank you. Bye-bye.